Hello everyone, welcome to this GGS webinar. The topic of today is going to be retrofitting ground gas protection and post-construction monitoring. Um, what does that mean? I'll let John tell you. But I'll just say a little bit first about um, what's going to happen after this webinar. So you'll get sent an email with a link to the recording if you want to watch back. And do check out our website for past webinars and other free resources we have online from GGS. And please do also during the webinar pop your questions down in the Q&A Q&A box at the bottom, and we'll get around to answering them at the end. But now I'll introduce John, who is our technical director at GGS, who is going to tell us everything. And yeah, I'll just hand over to John.
Thank you very much, Louis. All right, well, good morning, everybody. I'm up here in Bonnie, Scotland. It's our GGS Scotland mug. And welcome all for joining in. So today I'm going to go through a little bit about retrofitting of ground gas protection measures and post-construction, in fact, monitoring full stop really throughout this process. Obviously, I can't tell you everything and go through all the designing and all that kind of stuff in an hour, but hopefully I'll set out a process from which you can follow and look to help through retrofitting measures where needed. As Louis already stated, please do ask questions. It's a learning webinar as well, so please type in your questions and I'll try and answer as many as I can at the end. So, without further ado, let's get on with retrofit and why we might need it. Well, there's lots of different reasons, but it could simply be that there's some modification going on. Okay, the existing structure's got gas protection systems in place, and you need to go and do something. You've got to put some new services in, which is not unusual, all those kinds of things, or it's going under a refurb. So how do you do that? Okay, that's a good reason. Another one might be that we've got a failure of a gas protection system. Okay, so in this particular one here, there's a gas protection system in place, and warehouse construction and gas has been found coming through various places. So we need to go back and sort that out. And hopefully we don't find too many of these. Okay, but where actual hazardous gases have been found within a structure, within a building, by which point, action has to be taken. So for those of you that joined on some of my previous webinars, particularly the verification one, I just want to reiterate this statement, which is, I'll read it to you. In the case of development, whether the hazardous gas source is natural or man-made, it should be considered an engineering and construction failure, where such gases are found to be elevated to a level that cause damage to property or adversely affect the health and well-being of users of that development. In other words, it's an engineering fault. It's our fault that structure's affected by gas. If we didn't know it was there, then why not? Did we fail in our site investigation and risk assessment element? Okay, and here are the sort of main reasons. We didn't do enough in the beginning to identify the problem, if there was one. Once we did, we then didn't do enough to design and specify the gas protection system, or we didn't really recognize what was going on properly. We then didn't install it properly, a poor construction practice, or we didn't maintain it and we didn't actually check it. So as you can see, they're all kind of built into one where ultimately you end up with sometimes, hopefully not very many, not in a good position. So what guidance is there that we can look at when it comes to retrofit? Well, I think I've been through on other slides before. There's plenty of it. And just to give you, 6 examples here where retrofit is mentioned, if not cursory, it's the full, there's even a full Syria document that talks about retrofitting hazardous ground gases in there as well. And I'm going to use a lot of what was in there within this presentation. So if you haven't got that document, that's a really good one to go and get. But the British Standard 8485 we've got there. We've got the BRE 211, which talks about radon. And then also basements, ground gases and structural waterproofing. There's a document there from the Basement Information Centre that talks about ground gas protection in those scenarios. So there are things out there that we can go and look at, go and read, go and learn. So please do grab copies of those if you haven't already. But just to show you kind of what the process is, I've come up with this sort of flow chart. And we'll go through this in a little bit more detail as we go through the presentation. But pretty much it all starts off with a trigger event. Okay, that then leads to some investigation and safety actions, probably the other way around if it's an urgent response. And then we decide what to do about it. And there could be all kinds of outcomes within there. So we'll go through some of that later on. Just one thing to really point out at the beginning there is that there is a route that you can bypass a lot of the sort of investigative actions to some extent, which is the simple repair process. For instance, that first example I showed you where you just put in a, shall we say, new service route through existing gas protection systems. Okay, so you don't really need to go through the whole kit and caboodle. You can just go and get on with the design and implement that safely. But in the bottom left there, you'll notice it's like all stakeholder engagement. Okay, and that's key with retrofit in all these different stages. Okay, so what do we mean by stakeholder engagement? Well, what about the people? Because retrofit, there's usually people using that building. Okay, so what are they using it for? How are they using it? And how are they going to be communicated to about what works might have to be going on? If, for instance, we've got a property that has gas issues, is there likely to be a wider issue with surrounding houses or buildings or structures? Do they need to go and be looked at? Yeah. We've then got the designers, the contractors, the consultants, stuff we're all comfortable with. That's what we do as our day jobs, our professional day jobs. But what if it is a bit of an event that's happened that you've got to respond to? You know, you're going to have the press knocking on your door. How are you going to manage that? What's the public relations? Are you going to need to involve emergency services? And last but definitely not least, the regulators. They can really help with this sort of scenario. And if you've so one of the things I would say, particularly in like a Part 2A process in here, is have a good communications plan created and ready to go before you actually go do anything, unless of course it's an urgent action. How do we look at who we need to speak to? We can think of, there's lots of different tools out there you could look at, but the example shown on the screen there is a radial network diagram of all. So each of those blue dots represents a stakeholder and how they interact with different other stakeholders in that kind of communications plan. So there are tools out that can help you figure out who to do that with. So what triggers retrofit? Well, it can be a planned response, which is the one we preferably like to go down. So we know we need to do something, and we can go and plan that with a bit of time, a bit of energy. So we've got some idea of what we're going to do. Unfortunately, sometimes we end up in an urgent response. Okay, so how might that happen? I'm a former local authority regulator. We might get odor complaints inside the house. The residents don't know what they are. And that can be a sign of gas ingress. Illness or symptoms associated with gases. It's like chronic exposure to CO2 can make a lot of people sleepy, a lot tired. Have they seen, unusual flames or smoke from cracks in the ground? That's happened in the past. Is there lots of dead and sick animals lying about, which we don't know are by animals? It's typically these kinds of things are things like rabbits, sometimes birds that you can see particularly on landfill sites where you get gas pooling, and particularly CO2 pooling in very still conditions. Yeah, or you've actually gone out, done some monitoring, and you found elevated gas conditions. So you can see that all of those areas might need a more urgent response. But even with the planned response, remember, you might find some of those things and you need to be prepared to get out there and do something about it. So let me pose this question to you. Yeah, you turn up, you find elevated gas in the building or confined space, and people or animals are in distress or inanimate. What do you do? Okay, so again, the reason for this slide is to make you think about what actions could you or would you take. Now I asked AI actually as to what their solution would be or what its solution would be, and it came up with this lovely little picture. Yeah, I wouldn't like to find myself in that scenario, but be aware that's there. So what does emergency responses actually respond? We'll have an actual response plan. How are you going to deal with it? Are your staff that are going on this site suitably trained? Can they recognize danger? Do they know not to put themselves in danger? Yeah. Most of the time it involves calling the emergency services and making the area that you're in safe and get as many people out as you can. Yeah, but without putting yourself in danger. Isolate ignition sources. So that's a light switch on there. There's enough energy in that to trigger a methane explosion if methane is indeed within the flammable gas limit around that point. So again, if you go monitoring with that suspect of hazardous gas, are you in there with intrinsically safe equipment? Yeah, and evacuate that area. From our point of view, certainly from GGS, we recommend that you train your staff to medium risk confined space. That should give them enough knowledge in order for them to actually recognise the danger and know what to do. Okay, so investigative actions. So what are those? Well, the thing again that most consultants will be familiar with is actually let's go and have a look at the data that's already there. Desk studies, historical maps, environmental searches. There might even be borehole logs from the BGS or even past site investigation and risk assessment data you can go and look at. Okay, and then from that, develop your conceptual model and modify an existing conceptual model. Okay, there's another few things there we need to look at. Then is then maybe structural or structure investigation. It's a retrofit, so there's a receptor already there, there's a structure already there. So very similar to what we do with a normal development site, is we go to a site walkover. We go and look at the actual structure, again understanding how it's built, what the potential pathways coming in might be. And I'll touch on this a bit later on. Okay, and then what monitoring are we going to do within that structure that helps us identify or understand whether we've got pollutant linkages? Okay, remember in both those scenarios, you're potentially going into a dangerous environment. You don't know it is or isn't. So make sure you've got that safe system of work in place. And then, of course, assessment of the data that you collect is important and how you go about doing that. So let's talk about a few more of those things in detail. So how do we go and investigate the structure? Well, one of the things that you should also do as well is actually understand who uses that building, and how are they using it? Where are they? Do they notice anything? Because a lot of the people that use these buildings will probably have quite a bit of information that will help you understand what's going on. In this, let's take radon for an example, which is a typical way that we see this. Radon is an issue for the actual persons exposed. Okay, it's not an issue for the building or the structure. It's you breathing radon in regularly over periods of time, and it can be very elevated in different rooms of the same building. So understanding where people are and where they're using it, how they're using it, for how long they're using it, gives you a great deal of information as to what their potential exposure is, and then what you could do to limit that while, say, mitigations having to be taking place. Okay, are they noticing cold spots, dead spots, hot spots, odors, and where are these occurring? Again, ideas for where you might want to focus or target some investigation, some monitoring, and of course, any physical symptoms, shortness of breath, all that kind of stuff is in there as well. So slightly different from what you might be used to, but very useful and particularly used in indoor air quality assessments as well. Okay. What about structural investigation? So once we've got into the structure, how do we look at that? Well, here's another AI generator. I'm loving my AI at the moment. AI generated picture of a typical building. I mean, I've never seen one quite like that, but it demonstrates the various pathways in to a structure. Okay, so let's take out this house. It's got three levels. It's got an attic that's being used. But you can see there, we've got soils and groundwaters. We've got pathways within there. We could have different foundation types. We could have cracks through the concrete slab, which isn't all that unusual. Yeah, concrete does have cracks. That's what it does sometimes. Okay. Does it have sources of gas to the property? It's being phased out in the UK, or at least the government is driving that way to stop gas supplies from, I think it's 2030, if not already. But there's still a lot of existing stock with gas supplies to the building. So again, a potential source of a gas, and of course, combustion of that gas in a poorly ventilated room can create elevated CO2. Okay, so it might not always be from the ground. It could be stuff going on in the property itself. Okay, what's the ventilation like? Is it good? Is it bad? Are they using it differently in summer and winter, which they probably are? And this is definitely what we see with radon. Are the chimneys? You're going to get stack effects within the property, all these kinds of things that you need to look at and think about. Another point on there as well, I've got cavity wall ingress. That's something that not many people actually go look for. But it's definitely a pathway and a route for ground gas to come in up through the foundations and find itself sometimes in higher levels where it's completely bypassed the ground floor and it's up in the loft. Again, how do we go and investigate those kinds of features? Okay, so lots of different things to go look at when we look at the structure. So that's one of the main investigation techniques is going and having a right good look at what's going on. Then we've got to think about, well, what gases, well, actually, before we've gone there, we should be thinking about what gases are we likely to encounter. And here's just some of the typical ones. So just remember, there's acute and chronic effects with all these different gases. Some have both. Okay, and just be aware of the different, what solubilities for, but most importantly is usually densities and at what level, at what concentrations these things become a problem. Okay, they are very different. So make sure that you understand those properties when you're actually investigating the buildings. Okay, and once you've done that and understand what you're likely to be looking for, what are you going to do when you go to monitor these? So importantly here, methodologies of sampling, how are you going to do it? So this is what we do at GGS. We have a fully documented step-by-step methodology for each kind of test method we use. Make sure it complies with relevant guidance where it's available. If it's not, make sure your in-house method is fully stated and justified with any limitations. Importantly here, and I'm sure some of you who will listen to this will have seen this, where the actual specialists conducting the test method don't actually know what they're doing too well. Okay, so make sure that they're fully trained and competent in what they're doing. Okay, and also that the equipment that they're using, is it operational? Is it calibrated? Is it certified? You'd be surprised how many instruments out there don't get the full maintenance that the manufacturers recommend. Okay, so therefore, is the data that you get not particularly great for your assessment. Okay, and when you're recording this data, make sure that it's done in the context of what's going on. So here's a small example of an internal survey that we've done, and we've tried to detail carbon dioxide, methane at different positions. We've tried to identify cracks in the floor and the walls, all kinds of details in there that we would help a risk assessor to understand what's going on. We've recorded the weather. We've done some fresh air tests before and after to show that the equipment is responding as we expect. Would we just do one of these, or would we do a series of these tests? Because guess what? Ground gases react to a lot of environmental changes in environmental parameters, such as pressure, or so particularly in housing, temperature might be a driver, which we see quite keenly with radon, for instance. Okay. So what are the monitoring methodologies? Well, there's lots. So here on this This slide here is some of the things that GGS does as our methodologies. So it might be internal continuous monitoring, it might be borehole or monitoring well continuous monitoring, spot sampling, grab sampling, vacuum cylinder canister sampling, walkover surveys, point source surveys, loads of different things you can apply. And I think in the bottom one there, we're actually doing a vapor sample as well. So there's lots of things you can look at there. But when you're picking your methodologies, again, remember what gases of interest we're trying to look at and look at the sort of resolutions we might need. So the choice of instrumentation analysis is critical to getting good data for your assessment. And as you can see on this screen here, we've got things like from parts per billion to percentage by volume. And of course, some of these equipment will change, we'll do both. So make sure you've got the right equipment for the particular task that you're doing. So whether that's grab sampling, time average, or continuous monitoring. And again, you can use a series of these different tests. So very important that you select the right methodologies and have the equipment that's at the right resolutions for what you're looking for. Okay, and again, in concert with the identified CSM. So let's just take an example here of some continuous monitoring, which is GGS's sort of specialism expertise for one of ours. So here we have some information taken by a gas sentinel, and as you can see here, the variability of gases at that particular location. So if you just eyeballing the results there from the pressure on the top graph to the middle graph, you can see there's a direct correlation there with atmospheric pressure. So if you are going to go and target events for monitoring, you want to be out there when that pressure's falling, and preferably at the lower part in the trough of that fall to get your worst case conditions. And again, you can see that data is repeatable. So let's take that a bit further. So if we go out and take these results when we do that pressure, we're likely to get a very different result from if we went out when the opposite was true. So again, timing of if you're going to do spot monitoring episodes is really key, and to demonstrate that properly. But what happens when unexpected results might show up? Yeah. Usually, and it wouldn't be the first time I've heard where people say, oh, the instrument wasn't working, it's not calibrated. We're going to ignore that data. But you really need to step back and think about, are you justified in doing that? And here's a perfect example here from continuous monitoring internally, where if we just zoom in on that bottom graph there, we've got some carbon monoxide showing up. Okay. And it's doing it in a cyclic fashion. It's not, to me, that wouldn't look like anything that's a sensor aberration. So there's probably something real there. But what could it be? Because we weren't expecting to find CO. So pretty much there's usually a reason. And in this particular event, yeah, we think this one was associated with how they were trafficking combustion vehicles in and out of the location at particular times during the week. Okay, so again, in this case, not a ground gas source, but still valuable information for indoor air quality. And of course, the client hopefully will take that data on board and go and increase ventilation when they are doing such operations and activities. Okay, if they need to. But again, a little thing, and I think anyone that was at the verification webinar last month heard me say, be very cautious doing internal investigation monitoring. Use the right tools, use the right methodologies in the right way. There's unfortunately a lot of people running around wafting these kinds of instruments around, not really know what they're doing and saying it's all okay. That's not professional practice. So, my message out to you today is really think and plan what you're going to do. Okay, so that's how we go. Some investigation sort of ideas. So how do we look at those results? How do we apply that to the structure? So we've got Sirius 795 that helps with that. Okay, and they've got a classification of hazardous ground gases within there. And it's set out in classes 1 to 4. And I think quite nicely. They've looked really more. They've used more of the words that are associated with the sort of Part 2A of the Environmental Protection Act here, using significant harm or SPOSH in the class ones and twos, and then three where SPOSH doesn't exist, and then class four where we're quite comfortable that there's not really anything going on there. But in all cases, you need to have your good data. Again, I'll reiterate that good data sets to actually classify this data. Yeah. So simply put, if it's class one, you need to act. You've got to do something. There's no question about it. Class two, well, there might not be that massive risk associated with it. There's clearly gases coming in there of uncomfortable concentrations, and really should be doing something about it. Class three, this might be kind of where you'd normally stick your planning kind of criteria. Well, there's no SPOSH at all. You do actually see some ground gases coming in. Okay. And that, well, there might not be a hazard or cause harm. Maybe our data set isn't good enough or robust enough or long enough to justify that nothing needs to be done. So therefore, on a precautionary basis, we should maybe consider doing something. Okay, and then class four, risks are low. We've got a really good data set. We're very confident in that data that's been collected, and even on a precautionary basis, we don't think anything needs to happen. Okay, so that's your classification of hazardous gases. And then just to give you an idea of what kind of numbers you might want to be looking at with that kind of classification. Again, this is in Annex A1 or something similar, Syria 795. Gives you some ideas for some of these gases. So methane, again, there's a kind of bracket between class one and class two there. Anything above 0.5% pretty much means sorted out. Class two or class three to class two, we're dropping down orders of magnitude, and then class four and class 0.01%. There's such a factor of safety in there that generally speaking, we wouldn't really be bothered. Okay. CO2 is very different. Even though it's got that higher levels within there for the classes as you go down, just bear in mind that carbon dioxide can have physiological effects at lower concentrations. Okay, and indoor air, the Indoor Air Quality Associate Air Quality, and now saying that pretty much if it's less than 800 ppm on average, or it's greater than 800 ppm, you might want to look at improving ventilation for good to increase air quality. That doesn't mean that it's a ground gas issue. Again, there's lots of other sources of CO2 from just simply people breathing and respiring in the building. Okay, cooking, all these kinds of things. But it is a factor to think about. Okay, oxygen is not something we tend to find a problem with in above ground structures, but certainly if you've got any basements or anything that any sort, it's very key. Oxygen's in there, and then radon. We've got some levels there that you can apply. It's been in guidance for a while. Just bear in mind again, background house value is about 20 becquerels in there as well. Anything less than 100 becquerels is deemed okay, but then above that, we might want to do something about it. I know you've got some domestic and workplace figures there that you can work from. Okay, but when you're applying these numbers, very similar with the GSVs, don't forget your conceptual sign model. Lines of evidence and data confidence as well in there. So once we've done our assessment, what can we do about it? Well, it could be a number of things, but it could actually be we don't need to do anything. Okay, we might need to want to go and collect more data so we've got higher confidence in what we're saying, whether we are going to have to do anything or not. You might actually find you've got to close part of the building, part of the structure. Okay, maybe temporarily while mitigation continues. Yeah. How are you going to manage that? Okay, back to our construct. And it might be phased. And don't forget, whenever we do any of this, we need to justify and show that any work that has been done has been successful. So that compliance monitoring. And ultimately, if we can't sort the problem out, or it's too costly, or it's liability, and maybe we just get rid of the structure. Okay, that is an option. So what can we do? What are the options? Well, we can improve ventilation, which is via passive or active measures we can extract. And I'll go on to what that might be useful for as well. We could seal cracks, we can seal pathways that are obvious, and probably in the last one is retrofitting membranes, okay, for these kinds of structures. It's not something that should be done lightly. There's a lot of effort and cost in it, but there are examples where we do that, we can do that. So when we are deciding what we need to do, we need to design it, don't we? And we need to specify what we're doing. And unfortunately, this is all too much. There's not enough detail being provided as far as I'm concerned in industry at the minute. There's lots of detail out there. There's lots of manufacturer product sort of little cross sections, but they're not site specific. Okay, they don't actually build into the structure that's there. So just like a new build, when you do a retrofit, you need to design it properly. You need to specify it properly to that particular building. And, you know, like other things, it's not just one person that does all this. You need a design team because your measures can affect several other things as well. Yeah, so make sure that you're involving your right team within there. So I'm just going to put up a few slides now of some example design. I'm going to take a simple example here. So we're going to look at some services. So this is a building, and the owner wants to put in some new services through the slab. We've got a little step in there for a change in level that's adds a little more complication. So how would they go about it? So here is kind of a schematic of a design of how we would do that. So it's laying out on the actual floor cut marks, and then it's describing how far we want those cut marks to go, because under this concrete is a membrane, supposedly intact and perfect. What we don't want to do is go and destroy that or make it really difficult to then go and actually seal that membrane up after the works. So how did we do that? Here we've got basically two stages of cutting to get to that point, and careful cutting as well. So again, nothing is rushed here, shouldn't be rushed. It takes time. Of course, time costs money, and contractors just want to get on with it. But this is where the design, you know, really comes to the fore, because it shows them what they can do. So when they're pricing for that work, they're doing it at a reasonable pace to what their expectation is. Okay, not just go in there, cut saws blazing, and off they go, which is unusually, sadly, what we tend to find, and we're called in after the event. Okay, and then just go through the different stages. Yeah, so this is stages 5, 6, and 7, which talk about basically reinstatement of the membrane, and then some verification and watch points of what needs to be done. So again, it's those kinds of designs and stage and show people what they're expecting to do makes things go a lot easier. Another thing that we tend to find missing are construction method statements. Okay, and here's a checklist here for what we might want to see from the different contractors. Okay, and that's, you know, shouldn't be unusual. Here's what are they doing? How are they doing it? What are they going to do if they break something or get it wrong or damage it? Are they actually skilled and competent in what they're going to be doing? Yeah, we're going through all of this with membrane installation for gas protection, but there's all the host of different elements of gas protection and follow-on trades that need doing. CQA regime, how are they testing the work they're doing? Yeah, do they do it at all? And I think those of you that heard my verification ones before, yeah, remember we've got our little gremlins running around these follow-on trades. How are they going to behave, and how are they not going to damage our gas protection systems? Okay, so don't forget those as well. We also need a verification plan. Okay, we're doing retrofit gas protection systems. There's no reason why we should treat it any different. And again, there's a list there of things you can go and look at. What you need to do, if you want to know more, get Sirius 735. Have a read of that. The one thing I will try and get in people's heads is actually the thought of having 100% of the gas protection system verified. Okay. The only difference here is how much of it is CQA by the installing contractors and how much of it is done independent verification. But if you have in your head 100% of it needs to be done, hopefully that will all get done and not just need to go and see bits here and there. Okay, there has to be an expectation that everything is looked at. And if you read 735, particularly the annexes in there, you'll see what I mean. That is there. It maybe not be stated in that way, but that's the intention of it. Okay, so what can we do? Well, once we've got all that design in place, specification in place, with the verification plan in place, the contractors are all good. How do we go do it? So what can we do? Well, a lot of retrofit, and by far the vast majority of retrofit in the UK is for radon. Okay. And you can see things like this. So this is a PIV, positive input ventilation system. And these typically go in loft spaces, as you can see in this particular example. It basically filters air, hopefully clean air from that's brought in. It pushes that down into the building and it creates a positive envelope within the building so long as the windows and doors are closed on the external frame. But even if they're open, it's still providing some fresh air. You probably see on the bottom right there, there's a sort of warning sign in there. That's got a heat recovery system, okay? So, or a heating element essentially warms up that air before it goes into the property because loft air can be cold, okay? The other thing to also think about with any measures you put on there, so this is the bottom end of that system, is it's got actually some fire protection in there. Okay, we're in this particular property, it's 3 stories, and therefore you need to think about fire protection, fire barriers, and it's got a pneumatic waffle on that. So if there is a fire, that stuff will expand and close that pathway off. So air doesn't come in and feed the fire. Okay, so don't compromise other safety systems while you're doing this work. Okay, just like you wouldn't expect anybody to compromise your work, don't do it to their work. Okay, so that's one area. Another one for radon, because again, it's the most thing that we do is installing sumps. So the left one, that's not actually a retrofit, but it just gives you an idea of what a sump is. It looks like a box under the ground that we extract from. So this is the extraction element. Radon is chronic, it's not acute. So this is quite good. Very good technique for this. And then you can see in the right-hand photograph an actual connected and activated sump system. So that's basically the pipe work and the inline fan that then ejects. So basically it applies suction to that sump box underneath, sucks the radon gas towards that point and ejects it out to air, not near windows and doors, by the way, but usually above eaves and above the roof. Okay. What if we need a bit more of a meaty solution? So we've got some warehouse stuff going on here. Again, in this case, we're not, rather than extracting the gas, we're actually blowing air in. Okay, so this is the clean air blanket system where we introduce air underneath the big slab to actually dilute the gases beneath the slab. And that can work really, really effectively on some of the biggest sites that we've seen. Okay. What about cracks? Okay, so concrete. Let's talk about concrete. I'm no expert in concrete, but whenever I've done investigations and looking for ingress, it's usually gaps or cracks in concrete where we find it. Again, so concrete in its structure itself, I mean, that's a major crack you can see in that photograph. It does happen. Interestingly, with these cracks is they don't happen instantaneously. You know, this could be 5, 10, 20 years down the line. So you've got to think about this when you're doing your original gas protection. Is your concrete going to be absolutely perfect for all those decades of use? Okay, my answer is probably not. You get cracks. Yep. So just bear that in mind. How do we fix these things? Well, there's all kinds of things. So one thing could be like the cross stitching here. You can see for a seeker, they're doing a waterproofing job in a basement. So that's resin injection. Okay, and then for maybe minor stuff, I've seen, maybe just use like a resin-based concrete flooring. But again, this needs maintenance. It will over time wear, particularly depending on the use of the property. So you're going to have to keep this system maintained and done. Okay. The other obvious source of ground gases, again, other than cracks, is ducting. Okay, so here's an example of a duct. Lots of services coming in, probably, but I mean, I don't know whether this did have ground gas protection or not at the time. It might have done. But it bypasses that membrane if there's one there. It's not been sealed. There's probably thousands of these things lying around in the UK. Okay, get it sealed. It's not difficult. There's an example that we can do and easy to apply in a scenario. Okay, and what about the simple repair here? So here we've got some trenching going in for some new services. The services are already in. It's now been sanded up, binded. The membrane that's already there has been exposed. Maybe not the neatest of job, but they've actually done quite a good job there on the left. And then on the right-hand side is the sort of retrospect membrane that's gone in before they reinstate the concrete slab. You might notice that that kind of shape there is like a body shape. I'm pretty sure that they would have quite liked to have put the verification engineer under that from GGS at the end of this work, because it is time consuming to get it right, and they're not expecting that. A lot of contractors don't expect and anticipate the time it takes to do this right. Okay, they need to have an expectation that this thing is going to take time to do properly. Okay, and then what about other options? So you've already got an old building, for instance, or a new building. Can we do things there? Well, yes, we can, and might be one where we can put membranes in. Okay, where we're bringing up the floor already. So that's on the left. And then on the right is how we've actually done it through a wall. So rather than knocking the whole wall down, we can actually there break out sections of the wall and seal through it. We then reinstate those bricks and we move on to the next section. You can do this in several stages around the building, and we can actually get that membrane fully installed throughout there. This is courtesy of Neil Salvage. I'm sure plenty of you know Neil. And it's something that has been done successfully. But again, time, effort, cost, planning. Yeah, it's not a quick fix. Okay, verification. Again, we're expecting there 100%. I've already mentioned this before, so don't forget that there as well. The difference again being the amount of time that the third-party verification is based on those four things there. Okay, that's Series 735. Okay, anything that you're not doing as an independent verifier should be done via the CQA process for the contractors. Okay, what's the difference? Well, very quickly, how the contractor manages the quality of their installation and what they're going to do to make sure that that happens, yeah, and how they're going to test it and document that. That's CQA. Verification, independent verification is something very different. Okay, it's done by inspectors that should know what they're talking about. Yeah, they have a verification plan to create, and they do their own test proportionate to what's going on. They audit the data and the CQA that comes from other people for all aspects of that gas protection system. And again, what does that look like in the report? Something like this. Okay, so there we've got the plan laying out what's going on there, and then the data that goes in after it. Okay. So we've got our verification reports in. We've gone through a lot of data in there. Again, listen to other webinars that we've done on verification. I don't want to focus too much on that today. But then compliance monitoring. So once we've done all this work, we've got the measures in, we need to test it. We really do. You can't just walk away at that point and say job's good. You've got to prove that your systems have worked. And we should be doing this for new build. We're just not doing enough of it. Okay, in some regards, particularly radon. So how much needs to be done? Well, depending on the risk, of course, that's variable, but I would have it in your head something along the lines of that first 12 months is quite critical to collect your data set to show that it's working and good. Okay. You develop that based on what the risks are, what you've done. Okay. Make sure, just like we did with the investigation, that the technologies, the methodologies, the equipment that's being used is suitable for the task. Has it got the right resolution? Has your sampling strategy got enough visits in place to actually attend, to actually get enough good quality data, strong confidence data to say with confidence that we are happy that those pollutant linkages have been managed and mitigated. Okay. On radon, and this is an example, the data there is actually radon. Has it actually worked? Okay. And it isn't unsurprising, with radon, because you only need such tiny concentrations in volumetric terms to cause a problem, hundreds of becquerels in there. You don't get it right first time all the time. In fact, sometimes you can go back 3 or 4 times to treat a radon affected property, depending on what you're trying to do and what sort of levels you're trying to achieve. So again, be prepared to go back in and do further work. Okay. But with compliance monitoring, depending on the risks, it might be something that is there for a long term. So, it might then be for the lifetime of that building going forward. So we pretty much say this with radon. If it's affected by radon, you need to retest at regular intervals, and that depends on the risk. So that might be every 14 months, so you get a variation over time of seasonality, or it might be every 3 to 5 years, depending on what the use is. So again, it doesn't go away. Once the problem's there, it doesn't go away, generally speaking, with radon. And the maintenance of whatever you've done needs to be considered as well. So again, that's compliance monitoring, very similar to the investigative monitoring. And there's, again, more things you can do. In fact, very similar methodologies and tools you can do to show that that is effective. And I'm going to raise this message again. Yeah, it's not wafting around an analyzer a couple of times and saying it's all good. Yeah, we're going to get false negatives, a false sense of security that's all good. And it's not based on science. It's not based on what the changes are in the gas regime going on. Okay, so if you're seeing that, or you're doing that, please really think about what you're doing. Regulators who are listening, watch out for it. Okay, it's happening at quite an alarming pace in some areas. But once we've done everything, or we've done our investigations, and we just don't think that it's actually fixable, potentially, what can we do? Well, we can remove or close that structure. It's a valid option. And why might you want to do that? Okay. Well, it might be it's just too high a risk. It might be that the costs of actually fixing the situation are actually more than actually rebuilding. That's not potentially a unusual scenario. Timescales might be ridiculous. We've got to do this, we've got to go back in, so on and so forth. And also, if it's private residential at the end of the day, some of those mitigation options we've talked about might not be available, because who's going to be responsible to maintain them? Yeah. So you're all right with radon because of its chronic risks, and you've got a bit of time to sort it out. But with methane, an acute risk, yeah, we're very much limited with what we can do there, and usually with passive systems in there as well. It could simply be political or even corporate viewpoints on liability. Yeah, it's too liable, risky for them to maintain or keep that going. It might be they can't get the guarantees and warranties from the works that it's going to be absolutely successful. And it could even be, well, it's not insured. All these are valid reasons why we might need to close that off. But not everywhere. It happens sometimes, but it is a valid option to consider. So that's our whistle-stop tour into retrospect, our retrofit approach. There's the sort of layout again of our process. Hopefully, we've kind of gone through all that system, all that today. Again, that green box there, maintain and monitor. Again, that's typically for years, if not the lifetime of the building. We need to think about that in there, because we've proven there is a ground gas hazard affecting that particular structure. So I hope you found that useful. Quick reminder there, we've got more webinars on our way. So the next one, actually, I think it's a few months off, is ground gas case studies on the 18th of June. In fact, there's one more than that. Well, so get yourselves on there as well. There's one on atmospheric pressure, which is really good. Don't miss that one, which is one of our premium events. But I'm open now for any questions or discussion.
Thanks so much, John. That was very interesting. I'll get started with some questions. There's been a couple that have come in. First one from Ian says, is it acceptable to use a gas clam for continuous internal monitoring of a small room, or is this equipment specific for use within boreholes?
Interesting question. So gas clam was the first generation of continuous monitors. We use gas clams. We've now got our own gas sentinels or air sentinels. You can configure a gas clam with different sensors that can give you better resolution that might be applicable to what you're doing. But generally, if you're going in with a normal setup, it's probably not good enough. You need to have better resolution sensors in there for methane and CO2. So what we're talking there, CO2 parts per million, preferably your methane, you need to be getting that down to maybe 50 ppm, ideally, for that kind of continuous monitoring.
Okay. And then someone has asked what the hazardous ground gas threshold for VOCs in ppm are, or
Ah, okay. Well, again, that's a very complicated. It's a good question, but it's a very complicated answer. It's very site specific. It depends on which VOCs you're dealing with and whether there's a mix of them. You've usually got to do this through a DQRA process, a risk assessment process, to figure out what what concentration you would end up with in the building. You might even need to involve toxicologists depending on what's going on or what you're dealing with. Um, and then it's a case of them measuring to make sure that that isn't achieved or isn't exceeded, usually over the chronic period. So, some longer timescale monitoring within the property. What else to say? It's usually based on your increased lifetime cancer risk is what it comes down to. But again, it's compound and compound mix specific. So it really is quite complicated when it gets to those things, unless it's a workplace. And if it's a defined chemical, maybe EH40, so the guidance that's available can give you some numbers about short-term and long-term exposure. In the right scenario, that could be quite a simple method of actually using that number as maybe your first thing to look at, like benzene, I think it's at 1 microgram or 1 ppm. Sorry, you could use that approach as well for workplaces, but for the residential setting, DQRA.
okay. I think that leads nicely on to the next question. Is long-term monitoring required for VOCs?
So is it a declining source term? Is it going to stay there? Again, all within your conceptual model. How are you managing it? How are you maintaining it? Again, with VOCs, it's not really in the guidance, but it's usually a chronic effect that we're worried about rather than acute effect. So you might manage that with air ventilation changes. So an active system. Again, that will mean managing, maintaining. I would say there's nothing wrong with doing a few compliance monitoring points going forwards to make sure that's resolved. If you're going to, it's declining source term or it's being removed. So, for instance, let's take an oil spill. They're not unusual. We have an oil spill from a tank or a supply pipe in a house. Um, Typically, what they do is they go in and treat the source. They try and remove as much as they can, and then you've got a residual left that will diminish over time. They put membranes and all kinds of stuff to do that, and then they test, hopefully with good robust methods to show that there's that risk is low. But over time, you probably wouldn't continue to do that too much because that source diminishes. But where it stays, yeah, you should really keep that system maintained and make sure it's checked.
Thank you. Should we do a couple more questions? Peter is asking, at what point do the contractor's QC system become acceptable to the verifier? Or does the verify need to see 100%?
So more a question really about 735 guidance from Syria of how much verification you need to do. So the higher the risk, the more independent verification should be required. Even up to 100%. So VOCs for as to build on from what we said, that's a high, generally it's deemed a higher risk, and therefore there should be a lot more independent verification done on those particular types of systems. If it's a lower risk kind of site, then maybe reach out to the contractors. And this is what we do at GGS when we do verification plans. We ask for the methodologies to put in our plans. And where we're not happy with the methodologies because they don't really understand what it is that they're doing on that particular thing, we go back and ask them, what are you doing about this? And this is the expectation of the CQA data we want to see because we need that to put in our verification report. So again, maybe communication there brings that out a little bit more better, but we do need to improve as a whole, I would say, on that front.
And then last question from Andrew. How do you retrofit a clean air blanket system?
Well, you would probably need to go and speak to the specialists that do that, but essentially, various different ways. They tend to, so we've been involved in a few of those. So they tend to mole underneath the side of the buildings. So it's a bit like putting a radon to some extent. We do zones of influence testing to make sure that we can get the influence underneath the building footprint or where we want that clean air blanket to extend. It's then commissioned and tested, and then we test. It's one of the things that we do is we actually test how far that works and whether those, the desired concentrations after treatment are where they need to be. And that's how it works. Sometimes it could need to be some breaking through slabs and stuff inside if there are particularly knotty areas to get at. But generally speaking, it's being done from the outside of the structure and in.
Mhm. Um, so we will leave the questions there for today. We've still got a few that have been coming in, but do feel free to reach out to us if you have any burning questions. We can get back to you. Yeah, thank you so much for today, John. And
Yeah.
as John said, there is no webinar in April, but the next one is a premium webinar, which is led by Andrew. And that's going to focus on research into the effects of atmospheric pressure and kind of updating some of the research and findings from last year, which is exciting.
Yeah, yeah, don't miss that one. That's really good.
Yeah.
If you can make that.
So yeah, do sign up for that one. And yeah, thank you so much to everyone who joined along today.
Thank you very much. Thanks, everyone.
Bye.